Hello, my name is Laura Mendoza and I am currently pursuing a degree in Industrial Engineering at the Polytechnic University of Madrid. I will now expose the impact of the emerging techniques in the fields of conservation and heritage restoration used by companies in Spain. For this end, I will present the main tools which enable the recreation of the inside of buildings and objects. Likewise, I will combine the main challenges faced by restoration companies and the considered solutions. Also, a practical case using the laser scanner technique will be displayed. The presentation will end with a brief analysis of the conclusions and recommendations which have been extracted. Cultural heritage is important because it represents the history and the basis of every civilization. To preserve it, it is essential to obtain accurate data for its reconstruction without damaging it. New technologies have opened a path to efficiently and accurately record complex structures to enable their forward representation, analysis, and archival. The main challenge faced by cultural restoration companies in Spain is the acquisition of accurate and detailed data from the antique buildings to ensure its preservation and reconstruction, as sometimes the documentation has lost with the passing of time or the location is not accessible for its study. Also, all buildings require an accurate analysis of the materials, structures, and their state to be correctly treated without its damage. Sometimes, data of the characteristics of the buildings has been difficult to measure and store digitally. All these details can represent a great challenge, and sometimes they can only be faced by the use of new technologies. I will proceed now to expose three useful techniques for it. These are thermographic camera, virtual reality, and laser scanner. The interest of the thermographic camera relies on the calculation and determination of different temperatures. This device is affordable in the market and provides high quality and easy to handle images for the analysis of buildings. Based on infrared radiation, which generates an electromagnetic spectrum, it enables the detection of bodies by forming luminous images. All bodies emit a quantity of black body radiation infrared. This radiated energy is converted into temperature values from data obtained, and once the temperatures have been measured, the images are processed so that they are colored and easier to interpret. But these colors do not correspond to the infrared radiation perceived, as the camera assigns them arbitrarily according to the intensity range of the infrared wavelength. That is why they are known as pseudocolors. Commonly, blue parts are assigned to the colder zones and red parts to the warmer zones. The information they provide has a great importance when it comes to the detection of pathologies in buildings. An example of this is the identification of surface cracks between walls which cannot be identified from the exterior. A different technique, which is getting increasingly popular, is the implementation of virtual reality via glasses or other devices such as tablets or mobile phones. These tools, combined with softwares, have opened a wide range of opportunities in the field of virtual design with a great degree of fidelity and realism. This technological revolution has excelled due to the immediacy and ease of the images obtained. It enables not only the implementation of the existing reality, but also the reproduction of the missing objects. With the degree of fidelity and realism achieved in virtual representation, its visualization can become true even when a physical visit is not possible. Many parameters must interfere to ensure that the representation is as realistic as possible. Some of these are the scale, proportional light of objects, as well as materials and their corresponding textures. The interface of this tool has been designed to adapt to the user and follow the movement of the body, making the experience more sensual and emotional. New applications are being created to enhance the interaction with the environment, making possible any kind of virtual change in it, from the interaction of different materials to new models of furniture. The virtual reality technique creates an experience that allows the users to freely roam through the space in real time. This makes it easier to visualize how the building should be reconstructed or restored. The combination of these experiences can bring up useful data in relation to the diagnosis of buildings, analysis of energy efficiency, and environmental quality parameters, such as heating, ventilation, or air conditioning. This tool is also beneficial in the field of cartography and topography since it allows the differentiation of terrain heights. One of the most modern instruments of heritage graphic documentation nowadays is laser scanner. This device is capable of analyzing an object or a scene to gather data in relation to its shape, texture, and colors, allowing the construction of three-dimensional digital models and measurements. Its distinction in the field of cultural preservation is due to its an aggressive approach that allows the obtention of three-dimensional models and documentation with a great level of detail. This tool can launch thousands of pulses per second that are reflected by the surfaces, and thanks to which a point cloud can be processed to get a recreation of the buildings. The scanner can measure the distance to a large number of points that are referred to the angles and the reflecting values of the different surfaces impacted by the laser. With the angular values and the distances recorded, it is possible to calculate the three-dimensional coordinates of each of these objects. Subsequently, a cloud of points is created from geometric samples, and these contain the information required, the distance between the different points to every object. Using them, the shape of the object is extrapolated to begin the reconstruction process. Through the modeling obtained from the point clouds generated by the scanner, the position in the dimensional space of each analyzed point remains clear. In a few moments, this tool provides comprehensive documentation of both the interior and the exterior of the building, making possible the digital preservation of this information for its subsequent archival. After the study of the options mentioned, the scanner laser was chosen as the most suitable technology. As an example of this, the application to the reconstruction of the church called San Fid de Solovio, located in Santiago de Compostela, was carried out. This study was conducted by the Laboratory of Heritage de SIC in Santiago de Compostela. To make it possible, the tripod scanner was located on the floor in every main accessible chamber, except from areas which remain inaccessible. This made more difficult the generation of the virtual representation of some parts of the building. On the outside, the field of view of the device covered completely north, west, and south of the building, although it was not possible to record most of the surface of the roof. A crane was used to reach the higher parts of the external walls. The field work was carried out in 7.5 days, and a total of 18 positions of the scanner were needed to acquire the data for the precise scanning of the walls and floors, according to the parameters listed in the table. With the combination of these positions, almost the total registration of the interior spaces of the chart was achieved, using 77 million points with all its coordinates during the process. After this phase, the information generated by the various positions of the scanner was merged and a dot of cloud of the building was created. This enabled the drawing of the lines of the main elements to obtain plans, elevations, sections, and perspectives. Using the AutoCAD software, a 3D model of the building was executed. These images show the model obtained after the scanning of the chart. Once the previous analysis was carried out, it was important to point out that using new technologies brings new opportunities, but it also brings some disadvantages. Among the advantages, it will be necessary to highlight the substantial reduction of time spent in the field work and the automatic and high-speed generation of 3D models with photographic texture and color and high quality. Regarding the drawbacks, certain environmental conditions are required in order to use the tools previously mentioned. Some examples of this are the extraction of the actual colors of the materials due to operation of shadows during sunny days and the risk of the devices being damaged on rainy days. Moreover, the height of the buildings added to the position of the camera makes the taking of photographs of the covers impossible. This issue could be solved with the implementation of drones, which have not gained a great popularity in this field yet due to the immature legislation regarding its use. In addition to this, inaccessible areas sometimes cause the presence of gaps in the 3D models. To conclude, it is sometimes necessary to clean the spaces of elements that obstruct the vision of the scene, which can become a laborious and slow phase with a great impact on the time of the process. Other important conclusion is that the laser-based technology was selected as the most attractive technology because it offers an optimal ratio between the time of dedication and the level of detail. 3D virtual environments generated by the laser scanner provide 3D support in architectural and urban surveying and documentation with different levels of detail. This is very important in the field of restoration. Finally, it is important to highlight that as the heritage is recorded and documented digitally, its dissemination becomes easier. With the collaboration of different institutions sharing this data and incorporating it to an accessible database, the knowledge regarding the history and the architectural characteristics of heritage would increase and its preservation would be enhanced. I hope the main aspects regarding the techniques explained and its influence in the preservation of heritage have been satisfactorily clarified. Thank you very much for your attention.